All right, well, welcome everyone. I am JJ. Let's tackle an example problem. So we are trying to find Ix and Iy for our area we have shown here. We're going to do this using integration in this video. There are other methods that will be shown in later videos in here. If you're looking for like the parallel axis theorem, take a look at a later video. For integration though, you're in the right place. So our steps we want to go through. First off, let's get an equation for y. So y equals, get it in terms of x. And an x equals, getting x in terms of y. So for y, we have y cubed is 2x. Let's just take the cube root. Now I'm going to separate that into two little pieces here. But my y should be equal to 2 to the 1/3 times x to the 1/3. Separate that into two cube root pieces is the same as the cube root of 2x. This will feel easier when we get to doing an integral with it. If I want to get my x equals, I can just divide through by 2. X equals y cubed over 2. And from there, I can go on and say, let's just work with Ix first. So I'm going to do Ix on the left here. Then we'll come in and get Iy on the right half in a minute. But let's redraw this general outline, because we'll draw in our differential strip on here. So I have my y-axis and my x-axis. Y and x. And my object looks kind of like this. We're coming out 4 centimeters in the x and 2 centimeters up in the y. So this point is 4, 2, that max point in both the x and y directions. But from here, if I'm looking for Ix, I want a differential strip that goes parallel to the x-axis. That'd be a horizontal rectangle. I don't want to cover up kind of this material out here on the left side of this because I'm not looking for I for that piece. Just this part in here, which means my differential strip, I shouldn't start at the y-axis. I'm going to start this out here at the right and draw it going over to the left. We'll have a strip that kind of looks like that. The height of this should just be, well, that's infinitely tall in the y, so that's a dy. But the width of this isn't just going to be x, because x measures to the line every single time. I could say, though, well, this entire thing is 4 wide, so we'll start there, 4. And then I need to subtract off from that a little bit from the y-axis to my line. Well, that's just x, 4 minus x. At the very bottom, x is at 0. My differential strip would be 4 wide, 4 minus 0 is 0. Up at the very top, I'd have an infinitely thin differential strip. It would have to be 0. 4 minus my x is 4. 4 minus 4 is 0. My area will be 0 in there. 4 minus x should be our setup for this. But then we can come in and say, well, I need to get towards my dA. My differential area for this one is going to be 4 minus x dy. 4 minus x dy. Or I want to get this to y dy. So this is really dA is 4 minus y cubed over 2 times dy. And that's what I'm going to set up to get my Ix calculation figured out. I know Ix is the integral of y squared dA. If I have y squared and dA and y dy, I have all y's and dy's, I can integrate that. Let's go ahead and fill in our pieces in here. My Ix should be my integral from my bounds on this. If I'm working with dy, I'm going from the smallest y value up to the biggest. That smallest is at 0, the biggest is at 2. Of y squared times dA times 4 minus y cubed over 2 times dy times dy. Which is when I integrate that, I'm going to get that this is Ix. Works out to be, I can factor that y squared in. So one integral of 4y squared and another one of y to the 5th over 2. This is going to get me 4y cubed divided by 3 minus y to the 6th divided by 12. And I'm evaluating all of that from 0 to 2. plugging in my numbers here, I'm going to get that my Ix, my moment of inertia about the x-axis, is 5.33 inches to the fourth. Which should be our first answer here. And we're really just going to repeat that for Iy then. So let's redraw our object here. I have my general outline. This is my y-axis and my x-axis. My shape is doing this. This point is 4, 2. If I'm looking for Iy this time around, Iy, I want an axis or a differential strip parallel to the y-axis. So that would be, like we show in our steps, a vertical rectangle. So we can get a rectangle sketched in here that goes straight up and down. The width of this is always going to be dx. And the height here, I don't need to do like a 2 minus y, because I'm starting here on the x-axis. I can just go straight up y every time. Will give me my height. Which means my area in here, dA, should be y dx. Or dA is y is 2 to the 1/3, 2 to the 1/3, times x to the 1/3, dx. And that gives me everything I need to figure out my Iy. Iy is my integral of x squared dA. I'm going to integrate from my smallest x to my largest. So Iy is our integral from 0 to 4 of x squared times dA, times 2 to the 1/3 times x to the 1/3 dx. Or this is going to get me, taking our integral, Iy is 2 to the 1/3, 2 to the 1/3 times 3 times x to the 10/3, x to the 10/3, all over 10. And we're integrating that from 0 to 4, our integration bounds. But all that's going to come together and get me that my Iy should be 38.4 centimeters to the fourth. And this over here shouldn't have been inches, that should have been centimeters. Centimeters, because our given units up here were in centimeters. But that will be our final answer for our problem. Hopefully this was useful for you. If it was, hit those like and subscribe buttons. Stick around, watch more videos. Let's get you in with JJ.